Testing? Oh, very good. Good afternoon, everyone. In this session here, this next hour, oh, there's an echo. I'm going to give you a brief introduction into some of the new features that are part of Windows 2000. My perspective, and my perspective always, is from user mode, nothing from kernel mode. So this is stuff that's available to you if you're writing applications, Win32 applications, directly for Windows 2000. My name is Jeffrey Richter, and I do consulting work for companies. I also go in and I do training for companies. And in fact, this hour presentation is a subset of a full-day Windows 2000 session that I give. For more information about that, this is the plugging, advertising part of the thing. I'll get it over with right away. We have a booth, David Solomon Expert Seminars, at the exhibits, and I'll be there after this session. If you want to come up to me and meet me, just say hi or ask me any questions. In addition, I have some brochures down here that you can pick up on your way out. I have my own website, and you can go to that just to get a little bit more information, my biography and whatnot. Also, if you want to email me, I accept email from people. I answer just about every piece of email I get, even if it's to say, I don't want to answer you. But go to my website before you do that. Please don't send me any source code. Please don't ask me if I want to hire you. And please don't ask me if I can send your resume to Bill Gates. These are very popular questions, and I don't know why people think I can help you with that. By the way, I've never been a Microsoft employee. Okay? I'm an independent person. For training information, we have this website at the bottom of the slide, www.solsem.com. Now, just a little bit more information about me, very briefly. I write the Microsoft Press book, Advanced Windows, the third edition of which came out in 1996, the fourth edition of which has been updated for Windows 2000, and I finished the writing last week. Oh, thanks. So, and it's a major, if I do say so myself, it's a major revision. I rewrote a lot of stuff and added a lot of new material to it. So that should be in the stores probably in about 2 to 3 months. We're doing the editing cycle now, but the writing is done. Okay, here's what I want to talk about. First, we're going to talk about, and a lot of my talk is kind of logo requirements driven too. So if you want writing an application for Windows 2000 and you want to get the logo on your application, these are kind of the hot points or things that you'll need to be aware of. So first, let's start off with power management support that's been added to the system. Now, Windows 95 and 98 already have power management support. It's nice finally to see it in Windows 2000. The goal, of course, is to conserve battery power, or even just to conserve power if your machine is plugged into a regular outlet at your house. And of course, this comes with the caveat that you don't want to be saving power and losing the user's data. So it's important that we keep the user's data and what they're doing alive, and we don't corrupt that if our applications are being conscientious of conserving power. Applications need to be aware when the system wants to shut power off to things. This gives your application the ability to say, I don't want to go into suspended mode. I need to keep running right now. You might not want the machine to be suspended while you're formatting the user's hard disk, for example. Kind of a bad idea. So in order to help this, one, applications will be sent notifications when the system wants to change its power state. Applications can at any time query the system and ask it what is the current power state. Am I running on AC power, for example, or am I running on battery power? If I'm on battery power, then how many minutes of battery life do I have left? Maybe you don't want to start formatting the user's hard disk if there's only a few seconds of battery power remaining. And an application should be checking this type of stuff, and it's required, again, in order to get the logo. And also, applications can inform the operating system of what their power needs are. And I'll give some examples of this as I go along. So first, there's how you get notifications, or what type of notifications you get. When the user is running on battery power or switches from battery power to AC power, a notification is broadcast to all the top-level windows. It's a WM Power broadcast window message it gets sent around. And that lets you know that the user has changed states. In addition, if the system is running low on battery power, another broadcasted message will go out. So applications will be aware that the battery power is running very low and it's been recommended to the user by the operating system that the user stop doing any work and change the battery or plug in somewhere so that they don't lose more data. An application can query the system to find out the current battery status by calling get system power status. And of course you pass to this function an address of a data structure, and the data structure will come back and you'll examine the members, and it will tell you whether you're running on battery power, AC power, what the battery charge currently is, critical, low, high battery power, or if the battery is currently being charged because the user is plugged into an AC outlet. You also get the remaining battery power in percentage and in seconds, and you get the full battery life on a full charge. So the operating system can be configured by the user to some extent. So the user can say, look, when the system is sitting idle for a certain period of time, then I want to start conserving power. And there's a new control panel applet that does this, which I'll give you a demonstration of momentarily. But basically what happens is there's an idle timer inside the system. And when the system detects that the system has been idle for some amount of time, again, this is settable by the end user, then the operating system can start shutting down power to different devices, such as the monitor, the hard disk, or can completely put the system into a suspended state as well. In some cases, certain applications won't want this behavior. For example, if I was running a PowerPoint presentation, like I am right now, I could talk about this slide for days. Believe me, it's true. And if I talk about it for 15 minutes, then my system's going to shut off power to the monitor, and you're not going to have anything pretty to look at while I keep talking. So PowerPoint has been modified so that it calls this function set thread execution state. And it calls that when you enter slideshow mode, and that tells the operating system that the display is required right now. And so power to the display should not be shut off. A DVD player application would also do the same type of thing. Then when I would hit escape to leave PowerPoint slideshow mode, PowerPoint would call this function again and say, all right, now just go back and keep the regular timer going when the system's been idle for whatever period of time, then shut off the power to the monitor. There's also ES system required, which tells the system that you need the entire system to stay awake. Fax software might need this. If it's listening in the background and waiting for a fax to come in, then the machine could power itself up entirely, receive the fax, and send it to you as a piece of email or something. If the user is playing a game and they're using joystick control rather than the mouse or the keyboard as their input into the game, then you would use ES user present as a flag that you pass to set thread execution state. And that tells the system that the user is still present, so let's keep the system alive. Now, really what happens when you call this function, that just resets the timer back to 0. So PowerPoint would have to keep calling this function continuously to keep resetting the counter back to 0. Or PowerPoint could, when it calls this function, or in the ES continuous flag, which just tells the system, pretend that the idle time has been set to 0 continuously. And then when I would leave slideshow mode, then it would call the function without the continuous flag, and then it would go back into its regular timekeeping. It's important that applications be power friendly. And this means that your application has to inform the system of your application's requirements, basically using the function I just described. Also, if your application is going to perform any type of long operation, you might want to query the system. You should query the system to find out if you're running on battery power or AC power. And if you're on battery power, determine how much time you think you're going to need to complete the operation and if there's enough battery power. And if not, warn the user. And again, this is a logo requirement. If the battery power is running very low, the system does broadcast you a notification. A well-written application will then take whatever data it has in buffers and flush it to disk. Even if the user has decided to continue running until the battery runs completely dead, it would be nice if you could somehow preserve whatever user's data they have there, and they would only lose what they have edited since their last save. Okay. For an idle time operation, you could also check a device before using it. For example, there's a new service in Windows 2000 called the indexing service. This service actually isn't that new because it's part of the NT4 option pack and ships with, I think, Service Pack 4 of NT4, but it has some new features in Windows 2000 where it's part of the core operating system, and in the background it periodically wakes up and looks for files that have changed on the user's hard disk. When it sees recently changed files, it indexes the content of those files and produces a database. Now when you use the new Find in Files dialog box of Windows 2000, and you say, I'm looking for documents that contain the word Microsoft in them, it immediately gives you the results. Whereas in NT4 and in Windows 95 and 98, you would search for documents containing some text. The system would actually have to open up every file on your hard drive, scan the contents of the files, and then show you the results. With the content indexer, the results are absolutely immediate, very, very fast. Well, the content indexing service, if I'm running on a notebook computer on an airplane, it could be that I've been editing a Microsoft Word document for a period of time and the hard drive has shut down. Well, the indexing service would have to spin up the hard drive to do its content indexing. But it could detect that currently the hard drive does not have power, and it can decide to postpone its indexing rather than waste the battery power to do the indexing now. And that would, of course, be a very good thing for it to do. Okay. Now, I'll just give you a brief demo here. On the taskbar of Windows 2000, it's actually optional. My Microsoft Watch is beeping. I have a talk to give right now. I have an icon here at the bottom showing me my power state. By default, this is off. So I've gone in when I installed Windows 2000, and I've explicitly turned this on. And you'll notice when I hover over the icon, it tells me the amount of battery power remaining and that my battery is currently charging because I'm plugged into an AC outlet. If I click with the right mouse button, I can adjust the properties, which brings me the new control panel applet. And here I can set different power schemes. You can add any scheme, you can create your own schemes. And here's where the user would set the timeouts for when the monitor power should be shut off and when the hard disk power should be shut off, when the machine should go into standby mode, and when the machine should go into hibernation mode. And for those people that aren't familiar with hibernation mode, it's one of my favorite features, although it doesn't work on my computer here currently, but it's just beta 3 I'm running. This feature, when you tell the system to go into hibernation mode, it takes the contents of your RAM and writes it out to a file on your hard disk. And in fact, if you look at the root of my C drive, you'll see that I have a file called hiberfill.sys right here. And that is my hibernation file. And if we looked at the size of it, well, don't look at that, but you see it's 127 megabytes because I have 128 megs of RAM in this computer. And when I put the machine into hibernation mode, it takes the contents of the RAM, writes it out to this file, and then shuts the machine completely off. So it's using no power whatsoever. Then when I come back to the machine and I turn the power on, the BIOS detects that the machine was shut off in hibernation mode, goes out to the hard disk, copies the contents of this file back into RAM, reinitializes the device drivers in the system, and the machine is exactly where it was when I shut the power off, with all the windows open and all my documents ready for editing exactly the way they were before. I strongly suggest to you that you close those documents, though, before going into hibernation mode. I've run into some problems with this. Okay, so use it cautiously, at least during the beta cycle. All right, and the user can set when they want alarms to go off and so on in here. All right. Now, multiple monitor support. This is also a very cool feature that when I first heard that it was being put into the system, I was afraid to try it, because to me, the solution for solving a problem is never add hardware. So I knew that this meant I'd have to open the computer, I'd have to put another video card in, and then there'd probably be all kinds of stuff I would have to tweak and adjust in order to get it to work right. But a friend told me that he just put another video card in the machine, rebooted, and everything just worked. So I said, all right, I'll give it a try, and that's literally all I did. So I opened the computer, put another video card in, rebooted the computer, and all of a sudden, both monitors were working just fine. I opened up Calculator on one window, and I could drag it between the two windows, and I invited people over to the house. I just had to demonstrate this to everybody. So I know for people who've used Macintoshes, this is not a big deal, but it was very cool. And there's 3 ways that you can set this up. What will probably be the most common way, which is definitely the way that I used it too, is the virtual desktop method, where the multiple monitors are each windows, if you will, into the one big desktop, which has my tray on it, and I can have the windows, and I can drag them and drop them across the desktop, and sometimes they'll be in this window, and sometimes they'll be in that window, and sometimes it'll be half in one window and half in another. By the way, I think there's a limit to 4 monitors that you can hook up. Okay? So you can hook up to 4, I believe that's the limit. And that's the most common way that this is going to be used. Another way that this can be used, though, is for screen duplication or remote displays, where you have multiple monitors, but each monitor is showing the exact same thing. That could be useful in my presentation scenario, where what I'm looking at on this monitor on my notebook computer is the same thing that I'm broadcasting out to the projectors that you're seeing in front of you. And then a third way is to have multiple independent displays. Here, of course, the monitors can be showing completely different things. This is also very useful in a presentation mode, and it's really the way I would like to use it. In this mode, on my notebook computer, I could have my slide and my slide notes. I could also have the whole outline, so I could kind of get a feel for what slide is coming next. But what is broadcast out from the notebook computer is exactly what you see now. So the 2 monitors can be showing completely different things, and that would be very useful. Of course, software has to be written specifically to work in this environment and to handle this type of thing. The only software I really know today that works well in a multi-monitor environment is Microsoft Combat Flight Simulator. Yeah. So that team, the Flight Simulator group at Microsoft, there are a lot of ex-Windows 95 and ex-Windows 98 guys that got sick of operating systems and thought they'd want to work on something fun. So after they added the multi-monitor support, they went over to the other group and said, well, now we get to use it. So there you have it. All right, for the virtual desktop, which is the most common way, again, that people will probably use this, you have a single desktop that spans multiple monitors. Oh, by the way, this is also a logo requirement. Okay, your application must work well in a multi-monitor environment. Okay, so you have to perform testing. And I'll name some applications that did not perform too well in a moment. In this environment, one monitor is considered to be the primary monitor, and the user gets to configure this using the Display Settings Control Panel applet. That control panel applet, which has been in Windows for many, many years, has been enhanced. If it detects that you're running on a multi-monitor system, its UI for its Advanced tab, I think it's the Advanced tab or the Settings tab, has changed a little bit, and the user can get to manipulate the monitors and choose which one is the primary monitor. The primary monitor basically exists for backward application compatibility. The left top corner of the primary monitor is 0, 0 all the time. So most applications run great if they're running on the primary monitor. And sometimes they run really well if they're not, but sometimes they have problems. And then it's your job to fix your app so it runs well, whether you're on the primary monitor or not. Part of the problem is that because one monitor is the primary and that top left corner is 0, 0, a secondary monitor could be positioned to the left of the primary monitor, giving it negative coordinates. And a lot of applications, when they request from the system what's the top left corner of the screen and they see negative numbers, they freak out. They just can't handle it well at all. Also, for applications that call systemmetrics functions to determine what's the width of the screen and what's the height of the screen, those functions will return the width and height of the primary monitor, just like they did before. So again, those applications will work fine if they're running on the primary monitor. But if they run on the secondary monitor and they request the width and height, they may not get back the right dimensions for the monitor that the window is currently on. There is a bounding rectangle to the desktop, and the bounding rectangle covers the entire virtual desktop. So it is possible to have one monitor here and another monitor here, in which case there's an area here and an area here that the user could drag a window to and drop it, but the user will not see it because it won't be on any monitor. So that's possible, and the bounding rectangle, bounds the whole thing. And that's something also you may need to be concerned about, because the user won't be able to find the windows if they drop them in the wrong place. Each monitor has its own work area, each monitor can have its own resolution, and each monitor can have its own color depth, which is kind of freaky when you're dragging stuff around. Now, for backward compatibility, most applications are going to run just fine in this environment because Microsoft has done a lot of work to the operating system components to make sure that applications written yesterday work fine today. So there are some rules about this, though, that you need to be aware of. There's a concept of an owning monitor. This is a monitor that owns a particular window. And the owning monitor is determined by wherever for that window, whatever monitor is showing the largest area. That's the monitor that owns that particular window. Whenever that window displays any child windows or owned windows, then the operating system ensures that the child and owned windows appear on the owning monitor. Okay, so the system tries not to create windows that span monitors because it's very difficult for a user to see that. Also, for me, particularly at home, I had a 21-inch monitor and a 17-inch monitor, and the window never lines up quite right. It's a little shorter in the 17-inch one, and it's taller in the 21-inch one. There's nothing you could really do about that. Whenever you maximize a window, the system ensures that that window maximizes to fill the owning monitor. The window does not maximize to cover the entire desktop. I actually like the way that Microsoft did this. I usually run Visual Studio on one monitor and Microsoft Word or the help on another monitor. And I maximize them both, and it's great, and I can just kind of look back and forth between the two very easily. The system also ensures that menus never span across monitors. So whenever you open a menu, it's going to go on the owning monitor's window, owning monitor. Okay, now, compatibility, most applications work as is. There's nothing to do. They just think there's one big desktop. The system metrics reflect the primary display. So if you're running on the primary display, you're fine. If you're running on a secondary display, you're not so good. So worst comes to worst, a user will see that your window's not behaving properly and can move it to the primary display. I don't know how a user will know to do that, but they had to set up the multi-monitor support in the first place and pick a primary monitor, so they should be able to figure it out. Full screen applications tend to show up on the primary display only. This is a problem for screensavers, for example. They need to be modified so that the screensaver covers all monitors now that are on the desktop. And because the operating system does window minimizing, maximizing, menus, and dialog boxes automatically, then there's usually nothing you need to worry about. Now, the compatibility issues that Microsoft has found with this, as I already mentioned, screensavers only cover the primary monitor, so their code needs to be fixed, and the screensaver has to be recompiled and linked. Some applications don't like negative coordinates at all, so you need to modify your code to be able to deal with that. Some applications restrict or center windows to what they think is the primary monitor. Some applications say, what's the width and height of the screen? They now get that back on the primary monitor, and they put themselves there, but the application window could be running on another monitor. Or another common problem is that they'll get the width and height of the entire desktop, and they'll center themselves on the desktop, which means that they will span across monitors. And that's not really good either. So you need to look for both of these things and fix them. Any applications that do direct hardware access may need to be fixed. However, Microsoft has already fixed the DirectX stuff, so that works well in a multi-monitor environment. It's already ready. So if you're using DirectX, there shouldn't be anything special that you need to do. Applications that patch GDI or display driver, which is really more of a Windows 95 and 98 issue, because applications can't really do that in NT. And worst case scenario, a user might have to completely disable the secondary monitors in order to run the application. Now, I'll just mention a couple of things that I saw. One thing I saw when running an old version of Word 97. In Word 97, you can go to the scroll bar, which would be on the right-hand side of the window where I'm moving the mouse right now. And if I clicked on the thumb in the scroll bar and I moved, it pops up a little tooltip that says page 1, page 2, page 3, and when I see the page I want to go to, I release the mouse button and that page scrolls into view. Well, once I was using Word on the secondary monitor and I hit the thumb and the tooltip didn't appear. And I didn't know where it went, and then I just happened to look over at the other monitor and it was over there. So it was working okay, it was good enough anyway. In an earlier build of Windows 2000, I was running Notepad on a secondary monitor, and I chose the File Open menu option, and the File Open dialog box didn't appear. And that drove me crazy, because the window was disabled. I couldn't pick any more menu options, but the File Open dialog box didn't appear. And then I realized that it did actually appear, but it was on the other monitor. Now, unless they fix this, Windows 2000 can't ship with the logo. But I think it has been fixed. I haven't tried it lately. Okay. One of the more exciting areas, to me anyway, has been the NTFS5 file system. They don't call it NTFS 2000. It's called NTFS 5. Microsoft has really put a lot of new features into NTFS, and we're going to go through some of those features now. Okay. First feature that they've added, which actually isn't new. This has been in the system since the very first version, NT 3.1, that came out, I don't know, 9 years ago or something like that. The feature is hard links. And this is the ability, only supported for files, not directories. This is the ability to have a single file on my hard drive, but multiple path names taking me to that one file. So a lot of times what I do when I'm working on projects, I have a common header file that I use in all of my projects. And what I've been doing is I create the header file, and then I copy it into this directory to build the project, and I copy it into that directory to build the project, and so on. And very rarely do I ever change this header file, but occasionally I do. And when I do make a change to it for this application, then I need to go back and recopy the header file into all the other directories. So now with this hard link support, which again isn't new, but with the hard link support, I can now put the header file once and then put different path names or names in these other directories. They all go back to the one place. And so if I open that file for editing and make a change, it's really being changed everywhere, because it's really only exists once on my system. This will be a lot of fun for end users, of course, because when the user does a directory, they're going to see the file in each directory. And if the user counts up the number of bytes that the file is using, then they're going to see that file exists 10 times, and they're going to count the same size of the file 10 times, but it's really only occupying space on the disk once. And we don't have good tools like the Explorer and the command line shell. Those tools don't really help a user out with this. So what is new for Windows 2000 with regards to hotlink? A function to create them. There was no way for us to ever create them before, even though the file system has always supported them. So there is a new create hard link function where you pass it one path name of the existing file and a new path name, and it creates the new path name and has it point to the same existing file. And that's what we get that's new. All the data streams and all the file attributes are shared by all instances. And you can delete any of them, by the way, and it's only when you delete the last one does that free up the storage from your hard drive. Another new feature of NTFS is this new type of attribute. You're all familiar with the timestamp attributes, like the date when the file was created and the date when it was modified. And you're familiar with other attributes like hidden, read-only, system attributes. But there's a new attribute called the reparse point attribute. And Microsoft originally had a very simple purpose for this. And the idea was sometimes a user goes to access a directory, and when they access that directory, we would really like to redirect them to some other drive. For example, on the root of my C drive, I could have a directory called CD-ROM. And when I do a directory of CD-ROM, I would actually like to see the directory that's on drive X, which is my CD-ROM drive. So it kind of unifies the namespace a little bit. And when you do a search from the root of your C drive down, you'll actually be searching across into the CD-ROM drive or into some other drive. that's on the system. That was the original purpose of reparse points. And here's how they were implemented. A reparse point attribute is a block of data that's associated with a file entry. And that block of data can be up to 16 kilobytes in size, which Microsoft thinks is very generous. They think it should be way less than that, but they give you 16 kilobytes in size. Now, whenever a file or directory is opened or accessed on an NTFS5 volume, the file system checks to see if that file or directory has a reparse point attribute. And if that attribute is not there, then the system does what it normally does. But if the attribute is there, then the file system opens up the attribute and reads the 16K out of it. The first couple of bytes in this block of memory is a reparse tag. It's called a reparse tag. And that identifies a file system filter that must be installed on the machine. The file system then opens the file system filter and notifies it and says, hey, file system filter, this guy just tried to access this file or directory. Here is the reparse point data, the 16K block. You get to do whatever you want now. And the file system filter can say, oh, well, he's trying to open the CD-ROM directory on my C drive. So what I'll do is I'll look at the remaining bytes in the reparse attribute. Those remaining bytes will have in it x:\/ for drive X. And the file system filter will say, all right, let's really go and try to open drive X instead. All right, that was the original purpose of the reparse point attribute. It did not take long for people at Microsoft to realize, you know, we could really hack the hell out of this and come up with lots of really creative uses. So in Windows 2000, the reparse point tag is used for lots of stuff. And here's another example. The Hierarchical Storage Manager. This is a new service that ships with Windows 2000 Server and above. It's not on Windows 2000 Professional. This service, again, runs in the background. Periodically, it wakes up, it scans your hard drive looking for files that have not been accessed in a certain period of time. And the administrator gets to say what type of files to look at and what period of time needs to go by before considering them old files that probably aren't going to be used again. When the Hierarchical Storage Manager finds a file that's probably not going to be used again, it then takes the file and copies it to offline storage, like a tape drive or maybe a writable CD-ROM drive. Then it frees up the storage on your hard drive, but it does not delete the file. It just deletes the contents of the file. Then it places on the file a reparse point attribute. And the reparse tag, that's the first couple of bytes in the 16K buffer, indicates the Hierarchical Storage Manager file system filter. So now, when you're using the Explorer and you're looking at your hard drive, you still see this file there, even though the contents of the file is put into offline storage. If you're using Notepad and you choose File, Open to open this file, the file system says, oh, I'm going to go open this file, but wait, there's a reparse point on it, so let me go notify the proper file system filter. The file system filter gets the notification and says, oh, I copied that to the tape, and it gets that information out of the 16K buffer where it went, right? So then it goes out to the tape, loads the stuff from tape back onto your hard disk, removes the reparse point attribute, and now allows Notepad to open the file. Now, of course, this may take some time for all that to happen. But that's how that works. And there's other uses for the reparse point too, but there's two really good examples. The change journal. The change journal is a database that is on every NTFS5 volume. The database is updated by the file system itself. Whenever any change occurs to any file or directory on the volume, the file system, when it's making the change, also writes an entry into the change journal database. So the change journal is keeping a record of every change that's occurring to the volume by time. Entries are sorted or added, chronologically. Now, the size is adjustable and most people won't even know that this is on their system. The usual size is a 16 megabytes size. So the change journal will occupy about 16 megabytes of hard disk space. Every record written to the journal occupies approximately 128 bytes of storage. It varies, of course, because the file name is stored there, and file names are variable length and size. Microsoft thinks that on a system that gets about 4 changes per second, that it'll take about 8 or 9 hours for the 16 megabytes to be full, and then it will start deleting old entries from the beginning of the file. The change journal is implemented internally using a sparse file, which I haven't talked about yet, but I'm going to get to that momentarily. Now, what's the advantage of the change journal? Well, as I said, it keeps a record of all changes that are occurring to a volume. Earlier, I talked about the content indexing service. This service periodically wakes up and scans your hard disk looking for files that have changed so it can index their content and put it into a database. Well, if you were going to write this type of application today, you would have a thread, probably an idle priority or very low priority thread, that woke up, scanned the user's hard disk, and for every file that it found, checked the last modified time with the last time you did a scan, and if the file had been modified since then, you would re-index the content of the file. Well, this is a very time-consuming and inefficient procedure to perform. Having a thread wake up and traverse your entire hard disk, which could contain literally millions of files on it, is very costly. Plus, you're faulting so much of the hard disk's data structures and directory structures into memory that you're going to be throwing other things out of memory for applications that the user is really trying to use. Well, the change journal fixes this problem. The content indexing service uses the change journal. When the content indexing service starts up, it says, hey, change journal, wake me up when entries appear. So now the content indexing service goes to sleep. When it wakes up is when you have run some application that makes a change to the volume. Then the change journal is aware of the change, wakes up the content indexing service, and says, hey, content indexing service, this file changed. And it can give it the exact file that has changed. The content indexing service can now go to that file, open it, index the content of it, and then go back to sleep. So the performance of the system is going to be greatly improved using this. The replication service, it's part of Windows 2000, also uses this. You have a directory with a bunch of files in it. Periodically, it wakes up, looks at those files, and copies them somewhere else. Well, that's what it used to do. But in Windows 2000, it uses a change journal. So as soon as a change occurs within the directory that's being replicated, the replication service is told that, knows exactly which file changed, wakes up and copies that file to some other directory, and then goes back to sleep. So this is a real big change to the system. And it's available to all applications. Now, I was so interested in the change journal that I started writing an article for Microsoft Systems Journal on it, which is going to come out in the September issue. Because that's the soonest they could publish it, because I already finished writing it. And I had so much to say about it that it actually became a 2-part article. So I think it's going to be in the September and October issues. And there's a sample program that I wrote that demonstrates the change journal. And I'll just give you a quick look at what the sample does. Okay. So first here we see that it's monitoring my C drive. I want the hourglass to go away. Okay. And there's some journal information, so we can query the journal, and we get the time when the journal was created. That's shown at the top, Sunday, April 25th. Every journal is given an ID number. These are 64-bit numbers, by the way, to kind of help guarantee uniqueness. Every entry in the journal is assigned a USN, or unique sequence number. And we can see the first USN and what the next USN is going to be. And these are not contiguous. They're actually offsets within the file for where the 128-byte record is. And I won't go through all of this, but what I will do is I'll run Notepad. And in Notepad, I'll just say test, and I'll do a file save as, and on the root of my C drive, I'll call it teched.txt. Okay. And my application, which was running in the background, woke up because the change journal woke it up and said, well, C:\TechEd, the file was created, and then for some reason, Notepad deleted it. I don't know why, but then it recreated it. And then it added some more information to it, and then we see it also created a link file. And this is in my recent directory, so that when I go to the documents list here, there's the teched.txt was added. Okay, so apparently the file save as dialog box added this as well, but the change journal is making us aware of this. The content indexing service could now wake up and re-index this information. All right, maybe I'll just let this run in the background. We'll take a look at it later. Okay, there's the slides. Okay. Sparse streams. When am I done? 4:30? Right? Yes? Okay, thank you. Okay, sparse streams. This is one of my favorite features. This is the ability for you to create a stream within a file and tell the operating system, I don't actually want any storage in the stream, so it won't occupy disk space for the information that you have here. So this is what I'm about to say is an oversimplification. But let's imagine that you have a file on the disk that's 128 kilobytes in size. And you tell the system that you want that information to be sparse. You don't want it to occupy all the disk space that it is occupying right now, which is 128K. Well, the system takes the file and divides it up into compression units. And compression units are 12 clusters long. By default, clusters are 2 kilobytes in size, so a compression unit is 32K. On NTFS5 by default. Inside the directory for that file, where that file is, there's a table. And the table says at offset 0, here's where you can find the information, and it's occupying, and in the example I have on the slide, I say 10 clusters. Now, if it's occupying only 10 clusters, that tells the file system that that information has been compressed. All right, because the compression also uses the same algorithm. That's why they're called compression units. Okay? So the way NTFS does compressions is very similar to the way it handles sparse streams. So now when I go and try to access anything in the first 32K of this file, the file system goes out to the disk and reads 10 clusters, which is only 20K of information, off of the hard drive, loads it into memory, decompresses it to its full 32K block in memory, and then returns that to the application. All right, so now I've told you how compression works too. Now, if a compression unit, a full 32K block, contains nothing but zeros in it, 0 bytes in it, then in the table, like we see for the second entry here on the slide, starting at offset 32768 in the file, 0 clusters have been allocated. So there's actually no clusters on the disk has been allocated for this 32K portion of the file. Now, if in your application you try to read from this logical area within the file system automatically returns 0 bytes to you. Okay, so to you it will look like 0 bytes are in the file, but it's not actually using any storage. And now if you attempt to write to a portion within this area of the file, then the file system will commit storage and allocate clusters from the disk to back it, and that portion of it won't be sparse anymore. But it may leave other compression unit size blocks in the file. Those will continue to be sparse. So earlier I mentioned this party game where you could have a single file on your drive, but lots of hard links to it. So the file exists once, but you're counting storage for it multiple times. Here on my hard drive, I've created another file called sparse file. And if we bring up the properties for this file, actually, let's do a directory of it first. Okay. So here I'm doing a directory. You'll notice the file, sparse file, is 16 gigabytes in size. Okay? That's a 16 gigabyte file. It's occupying quite a bit of hard disk space. However, if we look at the root of my C drive here, and we view the properties for that, you'll notice that my hard drive is only 6 gigabytes in size. Pretty astonishing feat, getting a 16 gig file on a 6 gig drive. And one last thing to show you about this, if I bring up the properties in Explorer for it, you'll notice that the size is 15 gigabytes, but the size on disk, this is a new thing that the Explorer shows you, it's only occupying 64K. Okay, so it's only using 64K of hard disk space, but it looks like it's using 15 gigs. So that's what a sparse file is. By the way, earlier I mentioned the hierarchical storage manager service. And I said when you haven't used a file in a long period of time, it takes the contents of the file and it writes it out, and then it frees up all the storage on your hard drive. So it's not actually occupying any hard disk space. But they turn it into a sparse file, and they set the size of the sparse file to what the size of the file was before. So if you do a directory, or if you look at the file in Explorer, it looks exactly like the file's there with its actual size, but it's not using any disk space. So sparse streams are sure to be a feature that's misused as time goes on. And end users will have no idea what's taking up space on the hard disk anymore. Okay. Go to the next slide. Okay, kernel changes. For the kernel, one big area that's changed for Microsoft is they've done a lot of things having to do with memory management. For most people running applications in the world, nobody will care about these changes. The people that will care are the people that are writing very high-performance server-side applications generally. Databases, where you want to have access to a lot of memory, or you want access to the memory very quickly. Or scientific or engineering applications where you just have enormous amounts of data, and basically your data doesn't fit into a 2 gigabyte or 32-bit address space. So the first change that they made, they try to break the 2 gigabyte barrier. Now they already did that for NT4 by adding this /3GB switch, which only works on the Intel platform if you're running the Enterprise Edition. That switch still exists on Windows 2000. But in addition to that, if you're running on an Alpha, a digital DEC Alpha, which is now Compax Alpha, that is really a 64-bit processor running a 32-bit operating system. And so as a 64-bit processor, it really has an enormous address space. So Microsoft has hacked up some functions in Windows 2000 so that called very large memory functions, VLM functions. And you can say to the operating system, I wish to allocate a very large block of memory, and it allocates it in your process's 64-bit address space, because that's really what you have. And it returns back to a 64-bit pointer to this block of memory, and you can go access it. Now, in reality, a lot of people aren't going to do this probably, because mixing 64-bit and 32-bit pointers in your code is a nightmare for most people. Right? You just can't simply pass these things around all over the place. So it's there, and it was the first step towards a 64-bit operating system. Plus, let's not kid ourselves, Windows 2000 was supposed to ship a long time ago with a different name. So now we're getting much closer to a full 64-bit Windows 2000, and these features are looking a little bit less attractive to people. Now, in addition to the very large memory, and one thing you should know about it is that your machine has to have gigabytes of RAM in it, and any memory you allocate with this way comes out of RAM, and the system does not page it to the paging file. So you could take advantage of this if you want very fast memory and you don't want it to be paged. Very fast access. Another very recent feature that they've added are addressing windowing extensions. And these work on x86, Windows 2000, and 64-bit Alpha Windows 2000, and 32-bit Alpha Windows 2000. On all versions of Windows 2000. This just works. And the idea here is, again, you have this limited address space, and you want to have access to larger blocks of memory. So with the address windowing extensions, you can tell the system that you wish to allocate a block of RAM. You're allocating physical pages of RAM. So you better have gigabytes of RAM in the machine, although it will work if you only have a couple of meg in the machine. But it's really designed for high-end applications. After you have that allocated, you'll be able to map it into your address space very, very quickly. Okay, in the order of milliseconds we're talking about. And then you can access that data, and then you can unmap that out of your address space and map another block in at the same location. And the mappings, again, are very, very fast mappings. And this physical storage is also not paged. However, for applications, it's going to require that you have a privilege enabled to run an application that's able to allocate physical storage from RAM that's not paged. All right, so those are memory management enhancements. A fantastic new thing that they've added, which I just have a million different uses for, is the job object. This is a new kernel object. For years, people have wanted a way to treat a group of processes as a single entity. Server applications very typically need to do this, where a client makes a request of the server, and the server spawns a process to handle the client's request. And that process may spawn multiple processes, but then the client goes away, so you want to kill all of those processes. In fact, even Visual Studio, when you're in Visual Studio and you want to build your application, you're running the CL command line compiler front end, which then runs the different versions of the compiler, different executables. If you say you want to stop the build, lots of different executables have to die. In Windows, there's been no good way to do that until the job object. So now with the job object, you have a way of grouping a bunch of processes together and treat them as a single thing. You can do that for the purposes of killing all those processes, but you can also set restrictions on the processes. And this is for a web server or any type of server. If you spawn a job on behalf of a client, you can place restrictions on that now and say, I won't allow this client to use any more than this amount of CPU time. I will not allow all processes within this job to use any more than this amount of committed storage. I won't allow more than 3 processes to run in this job at any one particular time. So, and this is even useful for placing restrictions on a single process. I frequently created just a single process, and I place it into a job so that I can put restrictions on that one process. All right, so job objects, they're kernel objects, and so they follow all the normal kernel object rules. You can name them, you can share them across process boundaries. All kernel objects can be secured with security. They group related processes together. They have a way for you to set restrictions on those group of processes. But in addition, you can also query the job and get statistical information back. And I have a slide showing some examples of that. Okay. The functions are very simple and easy to use. There's a create job object, which returns a handle, open job object, assign process to job. You pass it a process ID and a handle to a job, and it associates a process with the job. All child processes of that job are automatically associated with the parent job. However, there are ways to override that, but the default is they'll just be there. Terminate job object kills all the processes in a job. You can query information, you can set information, and you can even restrict processes in the job from access to user interface objects, such as the clipboard, or from calling exit Windows EX to log off the machine or shut down the machine, or from windows in the system. So a process in a job, if it attempted to broadcast a message to other windows in the system, that you can put a restriction on the job that doesn't allow that to happen. This last function, user handle grant access, is a way for you to set the restriction, but then say, I will let processes in the job talk to this one window. Okay, so you have a lot of fine-tuned control over the job and what kind of restrictions you set. So here's an example of the basic limits that you can set. There's per process and per job user mode time and kernel mode time. There's a minimum and maximum working set size. Number of processes that can be in the job at any one time. You can set processor affinity, so I'll only let these processes run on this one CPU on the system and freeing up the other processes for doing other work in the system. You can also enforce a priority class. There's user interface restrictions. I already mentioned a few, like you can say, any calls to exit Windows or exit Windows EX would log off or shut down the system, fail those calls. Any access to non-job created user objects, reading the clipboard, writing the clipboard, or changing any system settings with system parameters info. So processes in the job couldn't change your wallpaper, for example. You can also set security limits and say every process in the job is running under this security context, and that's it. They can't change that. Things that you can query about the job are the total time spent in user mode and the total time spent in kernel mode. You can also set time periods. You can reset the counter to 0 and then query it and say how much time has the job used up now during this last period. Then reset that to 0 and say, well, how about now? You can get the total page faults, total processes that have ever been in the job, number of active processes, total terminated processes, and you can also query the list of processes that are currently in the job. I wrote another sample program, if I can find the directory, here it is, just for playing with jobs. Here, so let me go and spawn command.exe. So I'm spawning command, and it's currently running inside of a job right now. Not that there's anything you can do to really tell that, because I have no limit set. But let me go and set a limit of 2. So I won't allow more than 2 processes to be in the job, and I will apply that limit. By the way, you can apply these limits and change them while the job is in creation. You don't have to kill the job and all the processes and then recreate it, which is another nice feature. All right, so now I have this one process in the job, and if I run calculator, I have 2 processes in the job, and if I run notepad, I get this not enough quota is available to process the command, because I set a restriction on this job that no more than 2 processes can run. Of course, if I go and kill calculator and then run notepad, then everything runs just fine. You can also get a lot of statistical information about a job, which I show at the bottom. Here I'm showing process IDs. You can also get notifications when new processes are added to the job, when all the processes within a job die. If a process in the job gets an access violation or an exception and fails for an unknown reason, you can get a notification of that too. See, the command shell just went away. I killed the program which killed the job, and that killed the command shell. Okay. Microsoft saw over time that there were a lot of people writing applications, and these applications were creating threads that waited on single kernel objects. A lot of people would create an event kernel object that would get signaled when some event happened, and then they would spawn a thread that the sole purpose of the thread was to wait on the event kernel object. When the kernel object became signaled, the thread would wake up, do something, and then the thread would kill itself. Creating threads in Windows is not cheap. It's a very expensive operation. The system has to do a lot of work to create a thread. Destroying a thread in Windows is also not cheap. It's a lot cheaper than creating a process and having the process die, but in general, these are not cheap operations, and you want to not be creating and destroying threads all the time. In addition, having threads that just sit around waiting on single objects is a terrible waste of system resources. If you have 10 applications running and each one of them spawns a thread purely to wait on a single object, it's a terrible waste of system resources. So in order to improve this situation, Microsoft has added thread pooling APIs, which are on a per process basis. By default, your application will not get a thread pool until you call one of the functions I show on this slide and the next slide. As soon as you call one of these functions, the system creates a thread pool for your process. The system will automatically be creating threads, reusing threads, and killing threads, but it has a great deal of heuristics on this. So you will not be creating and destroying them all the time. It's really going to try to do it in a very efficient fashion. This is going to save system resources. It actually makes less code for you. When I started playing with these, I no longer call create thread, and I ignore a lot of initialization and cleanup issues. I just call one of these functions, and all the thread creation and destruction is just managed for me. So it's really nice. So less code. So here are the things that you can do. There's basically 4 things. The first thing is you can call this function register wait for single object, which is similar to the old wait for single object function, but here the register function tells the thread pool, first create yourself if you don't already exist, and then have a thread that waits on this kernel object. When the kernel object becomes signaled, call this function, and you pass the address of the function for the second parameter, and the function will be passed the third parameter here, so you can get some context information into the function. The function will also be told whether the object became signaled or whether you timed out while waiting for it. And there's some flags that you can fine-tune this behavior. So now a thread in the thread pool will be created, or it may use an existing thread in the pool. When the object becomes signaled, your function will be called. You must be aware you're being called on a thread pool thread that you did not create. So there's some thread synchronization issues here that you may need to be aware of in this callback function. So make sure you do the right thing. There's an unregistered wait that cancels a wait. Another thing you can do is you can queue an asynchronous work item. It could be that your code is running along, and all of a sudden you get to a point where you want to just have something happen in the background. So normally you might spawn another thread that does this thing in the background, and then the thread dies. Well, now what you can do is call this queue user work item. You pass in the address of the function and a value to pass to the function, and that says to the thread pool, wake up some thread in the pool, have it go do this thing. When the function returns, go back into the pool, don't necessarily die, but you can queue up several of these and have them all done asynchronously. Another thing that Microsoft noticed, especially for people that are doing protocol work, where they're communicating using various protocols, a lot of times you will initiate a request to some service. And if you don't get a response back in a certain period of time, you need to assume that the request has failed and somehow notify your user. So what a lot of protocol people were doing is every time they initiated a request, they would create a waitable timer kernel object. And they would set the timer to go off after a certain period of time. So now if the request came in, then they would assume that the request came back, okay? And if the timer went off while they were waiting for the request to come back, then they would assume that there was a timeout and they would cancel the request and go doing something else. Well, what Microsoft saw was that the system was creating lots and lots of kernel objects, or the applications were creating lots and lots of these waitable timer kernel objects. And while they're inexpensive compared to a lot of other things, they're hardly cheap. So it would be nice if there was a better way to manage these things. So that's what the timer queue part of a thread pool is all about. So you can say now that you want to receive a notification after a certain period of time expires. What your thread pool does internally is it creates one waitable timer kernel object. And then every time you say, I want to be woken up in this time frame or this time frame or this time frame, internally the thread pool is keeping a list of which one should go off next, the one that's most likely to happen next. And then it sets the timer to go off at that time frame. So it's managing the timer for you, so there's only one kernel object. And it has a thread pool thread that's doing this, so the threads are being used efficiently as well. And then the last function is bind I/O completion callback. And this is a way for you to say, whenever I'm doing I/O to this particular device, be it a file or a name pipe or a socket or whatever, whenever an I/O that I have, an asynchronous I/O that I have queued up completes, call this function. That's the second parameter. And that'll use a thread pool function to let you know that this asynchronous I/O completed, and now you can do whatever you'd like to in this other function asynchronously on some thread pool thread. Miscellaneous functions. The first miscellaneous function is this one called create process with logon W. It only exists in a Unicode version. That's why the W at the end. They didn't make an ANSI version of this function. People have wanted this for a long, long time. This function allows you to spawn a process as another user. Now the system has actually had that. There's a create process as user function that's been in the system for many years now. What makes this function different is that the spawn process runs under a different security context interactively. Okay, interactively is the key. So let me give you an example of this. Let's see. In my directory, I've created a file called xxx.txt. And I've set some security on this file. Okay. Oh, that's the wrong file. Here it is. It's this file I want to look at. Okay. On this file, I've said that Jeffrey Richter, that's me, has full access to it, and everybody else is denied access. Now, I happen to be logged on as me. What a coincidence. So when I double click on this, Notepad opens the file and it says this file has some text in it. No big deal. Now, I've created a shortcut to Notepad, okay, and I've placed it on my Start menu. But Microsoft, let me show you what this shortcut looks like. Let me bring up the properties for it. They've added a new checkbox here that says Run as Different User. Okay, this is a very cool new feature. I've turned that on. Then I hit OK. Now when I try to run this Notepad, I get this. And it asks me, who do I want to log on as? So in here, I created an account called Bozo. And password is also Bozo, in case any of you steal my machine. You can log in as that. I hit OK, and now Notepad is running interactively, but as Bozo. If I now say File Open, and that's print, File Open, and I go to that directory with that file in it, Drive C, right here, this one here, and I try to open it, I'll get I don't have permissions to open this file because Notepad's running under different security context. And really all that's happening is the shell is presenting this user interface, and you fill out these three fields, the username, the password, and the domain or the machine name. Those three parameters get passed to create process with logon W, as well as the path name of the program you want to run, and in which case in here it's using Notepad, since that's what the shortcut's for, and then it runs this. Now, I'll also tell you that the way that it does this is there is a service that has to be running on your machine. It's called the secondary login service. And if that service is not running, oh, you're not supposed to see that yet. Hold on. Okay. All right. See, I have single click turned on, and now everything's going to have pot. If that service is not running, then create process with logon fails. Okay. Finally, the NT team broke down and added the tool help functions to Windows 2000 as well. So if you had tools that were written for Windows 95 and 98 that enumerated the processes and the modules within a process and so on, those programs now work source code unaltered on Windows 2000. There's a new function that will tell you the service pack and build number information. There's an isDebugger present function, which is actually not new for Windows 2000. It's in NT4, but it is now documented in Windows 2000. And that will tell you if you are currently being debugged. So maybe you want to have some piece of code execute if the program is being run under a debugger, and a different code path if you're not being run under the debugger. Initialize critical sections and spin count. This is also not new. That was actually in a service pack, but I put it up here as a public service announcement to you, that these functions are better than the initialize critical section functions, and it's recommended you use these instead. You'll get better performance on a symmetric multiprocessor machine. There's also a new isProcessor feature present function where you can tell whether or not the floating point's being emulated because you have the floating point bug on your Pentium processor, and some other MMX extensions available and so on. That's processor specific. For user interface, they've added these things which were originally called windowless windows. What Microsoft saw here was that a lot of applications were creating windows that were forever hidden. They were purely being used for doing message communication between applications. Well, creating a window is also not particularly cheap. A window has a data structure to it. Windows have Z orders. They have to be inserted into linked lists, and there's a couple of linked lists that they go in, one for the Z order and then for the position within that particular Z order. And they have to keep rectangular information about the window on the screen and so on. So in order to reduce the overhead for windows that are purely being used for message communications, they created these things called message windows. And they used to be windowless windows is what they called them, but they thought that'd be too confusing because these windows never appear on the screen. Okay, they're always invisible. And to create one, you simply call create window or create window EX, and you pass in the special symbol hwindMessage for the parent parameter. And this window will never be visible. It has no Z order. It will not normally be enumerated. However, the find window EX function has been enhanced. So if you pass for the parent hwindMessage, you will be able to locate message windows. And if you pass in null for the parent and the child windows to this function, it will then also enumerate the message windows. For GDI, they've added layered windows and alpha blending. And layered windows were added to support, oh, I don't want that. Let's see. Okay. To support this guy here, okay. Mr. Clip. You'll notice that in Office 2000, the character is out of the box. He used to be in a rectangular window, and the reason why he was in a rectangular window is because painting was a lot faster. But now he's a regional window, an odd shape, not rectangular. And as he moves and shifts his position, the window behind him receives paint messages and needs to paint itself so that you can see the text in between the curve of the paperclip. Well, this is really hurting performance significantly. So layered windows were added to the system so that this character appears in a different plane, if you will. And as he moves and shifts around, he has no effect on the information that's behind him. The operating system's effectively keeping layered windows in a separate plane, so windows behind it will not have to receive paint messages as the character moves. So this was the motivation for it. Oh, man. And in addition, they've added alpha blending, which is the ability for you to put one image on top of another, setting a degree of opacity. So I've written a sample program to demonstrate this called Panos. So here's an example of alpha blending. You can see the window behind it somewhat as it's being faded in and out. And here's a layered window coming on top. The notepad window behind it and the PowerPoint window partially behind it are not receiving paint messages as these windows are going along. To further demonstrate my point, I'm going to run the zoom in utility that ships with Visual Studio. And you're probably aware what zoom in does. I can hover over something and it magnifies what is underneath the mouse cursor. Well, you'll notice that when I move it where the car is, let me slide this window down a little bit. Okay. I never get the car, okay, even though you see it. And if I hold it over here, I never get the car racing across. And that's because it's in a different plane and zoom in isn't able to catch it. By the way, this car is called the Panos car. It was created by David Panos. He used to work for Ford. And I saw it in a store once, and I thought, hey, this is a pretty cool car. So I walked over to it, and I tried to open the door to get in. And if you look very carefully, you'll notice there's no handle on the door. So I asked the guy at the store, I said, how do you open the door? There's no handle. He says, the handle's on the inside. So you have to put your hand on the inside and then open it. And I said, well, that's fine, but what if you have the roof up on the car? He says there's no roof. So I didn't end up buying it, and I thought they're not going to sell many of these in Seattle, which is where I live. But it was pretty cool looking. Okay, yes. Okay. They've added a bunch of other parameters and things that you could tweak. There's mouse hovering dimensions and time, so you can do single-click selection. There's X-mouse behavior built into the system for those people that like that. Combo box and list box animation so that when you scroll, the pixels slide up the screen rather than have it just repaint. I don't know what we've ever done all these years without gradient captions. To me, the system's not worth using unless you have the dark gray on the left and the lighter, or the dark blue on the left and the lighter blue on the right. Accessibility features have been added, some power management stuff which we talked about, alt-tab switching. A program can now determine whether or not a screensaver is running or not. And another one which I don't have on the slides, right, but I don't know how we lived all this time without this. Notice what's missing from the menu bar are the underbars. Right? The F in file is not underlined, so I don't know that hitting Alt-F is going to appear. That was just way too much screen clutter. All these underbars are gone. And if you open up a dialog box, all the underbars for the controls are completely gone until I hit the Alt key, and then they all appear. All right, so you want to know why the system's shipping so late. This is part of it. Oh, and how does the user set this? Because this is an option, you know. You can't just take something away and make it the default. So the user can set this by going to display settings, and on the effects tab, they can choose the hide keyboard navigation indicators until I use the Alt key option, which pretty much states it succinctly. There should be no question as to what that does. Okay, so a couple of last things here. Miscellaneous, they've added a function now where you can query the amount of GDI and user resources that an application's using. And they've exposed this in the task manager. So in the task manager, I can select the new columns here, GDI objects and user objects, and add them to the list. So this is very useful if you have an application. If the numbers are growing without bounds, you know you're leaking user and or GDI objects. By the way, they've also added I/O counters. So from a single process, I can now see how many I/O writes, that's individual write operations, or how many bytes have been written from this process. They also do reads, and they also do anything other than a read or a write. And by the way, this was in NT 3.1, and they took it out for NT 3.5, which was codenamed Daytona, to make NT run faster, and nobody missed it. So they just simply uncommented the source code and put it back in for Windows 2000. All right. There's a function where you can now determine the number of milliseconds that have elapsed since the user's last input, and you know the power management tools are using that to know when they can shut off power to the display and the hard drive. There's a function you can call to simulate or to lock the workstation programmatically, simulate the user hitting Control-Alt-Delete. There's a send input function now where you can force a sequence of keystrokes and mouse events into an application. There's always been functions that would let you simulate a keystroke or a mouse event. The problem was if you had to do several of them, the user could be typing or moving the mouse at the same time, and the stream is all intermixed. Now you have a way to send in the whole stream. The keyboard and the mouse are locked until the stream's finished, and then they're unlocked. Track mouse event function. If you're interested in receiving mouse hover messages and mouse leave messages, you need to call this function to tell the system you want to get them. There's a new HTML resource type, no big deal. And there's a lot of new common controls. There's an IP address common control, a date time common control, and a bunch of others. And that's about it. So I'll stay up here for a few minutes to answer some questions. Thank you. And then I'm going to go and be at the exhibit booth after I leave here. And please fill out the evaluation forms.
Question about
Yes.
NTS. If now you can use the registry